Oftentimes, we're just interested in the molar concentration of specific ions in our solution. So when you're dealing with a strong electrolyte, for example, all you really need to do there is multiply the molarity of the compound from which the ion comes from by the subscript of the ion so that you can get the molarity of that particular ion from that compound. Usually what we do is we draw square brackets around the symbol for the ion to imply that whatever number we assign to that is the molar concentration of that ion or molecule. So the word species here refers to is a generic term for either an ion or a molecule that might be in your solution. Okay, so let's look at an example. What are the molar concentrations of sodium and sulfate ions in a solution that's 0.5 molar sodium sulfate? So you say the molar concentration of sodium, so you put Na plus, the formula for the ion, in brackets, okay, is equal to 0.500 moles of sodium sulfate per liter of solution times, there's 2 moles of sodium ions in 1 mole of sodium sulfate. So basically you're only interested in the sodium ion. So this is, when you cancel mole sodium sulfate, that gives you an answer equal to 0.5 times 2. So that's 1.00 moles of sodium ions per liter of solution. So you can just put big M there, so 4 moles per liter. Now, you don't have to put that big M there because the brackets right here implies that whatever number you have here is in moles per liter. Okay, so but if you want to be complete thorough, then you can put the liter there. So 1.00. Essentially, what did we do? You multiply 0.5 by 2. Okay, remember, a mole is just a way of counting, and it's a group count, and subscripts in your formulas are just counting numbers. So what would be the concentration of sulfate ion? Then you're going to say I have 0.500 moles of sodium sulfate per liter of solution. Multiply that by 1 mole of sulfate per mole of sodium sulfate. Okay, so whatever the subscript of sulfate is, it's not 4, it's 1. Okay, they have 1 of the sulfate ions there in 1 formula unit of sodium sulfate. So this is going to be equal to 0.500. Let's try a more challenging example here. What is the molar concentration of chloride ions, if you recall chloride is Cl minus, in a solution that is 0.10 molar with respect to sodium chloride and 0.20 molar with respect to barium chloride? What this means is you have a solution that has not just sodium chloride but barium chloride, and you're given the molarity with respect to sodium chloride and barium chloride. So to answer this question, all you have to do is figure out how much chloride can you get from the sodium chloride and how much chloride do you get from barium chloride, and that gives you the total chloride concentration. So I'm going to say the chloride concentration in this solution comes from sodium chloride, so it's going to be 0.10 molar from sodium chloride. Okay, so I'm going to say moles of sodium chloride per liter of solution times 1 mole of chloride for 1 mole of sodium chloride. Okay, that gives me the molar concentration of chloride coming from the sodium chloride. And then I add to that 0.200 moles of barium chloride per liter of solution times, there's 2 moles of chloride in 1 mole of barium chloride. Okay, so basically what you end up doing is you multiply the molarities with respect to sodium chloride and barium chloride by the subscript of chloride in those formulas. And so what we end up getting here would be 0.1 times 1. So this thing right here on top is 0.1, this is 0.4. So that's going to be 0.500 moles per liter. Okay. Now would be the chloride concentration in this solution.